Okay, thank you folks for joining us for our last honors program colloquium of the spring 2023 semester. A bit terrifying. This colloquium is sponsored by the Academic Honors Program and the Texas Beta Alpha chapter of the Alpha Chi National Honor Society. We are very, very pleased to have one of our honors students, Dustin Higby, seen here, who's going to be presenting to us today as a mechanical engineering major on development of interactive teaching aid material for engineering courses. So we're going to let Dustin go ahead and present, and then afterwards we should have some time for questions. And thank you. Dustin, take it away.
Yes, feel free to
turn off. Okay, go for it.
Okay, so as Dr. Nakashian said, the colloquium today is over the development of interactive teaching aid material for engineering courses. So as we define the problem is we have flat, unmoving 2D representations in our textbooks. These representations often cause a little bit of spatial disillusionment about what we're looking at, especially when we deal with problems in the 3D real world. Often things don't meet at right angles like we want them to. And often a 2D piece of paper can't offer the depth that we need to understand that problem completely. So we have a lack of specific material. There's a lot of material out there in 3D, in animation, but there's a lack of specific material given the problems that we have in our current textbooks. So there's, to elaborate on that, there's a big gap between what the problem is in the textbook with what the animation is that you can find out there that's being published for use. So say if we want to show a pen flipping, we can probably go find some animation of that, but we can't find an animation of the pen in the book flipping with these certain aspects. Another thing is rudimentary animation. So we can actually watch this quick rudimentary animation right here. And you can see it doesn't quite follow that line real well. This is done by a PowerPoint animation, and we'll get into that a little bit more later. And hands-on experience and spatial awareness is a massive problem, giving the kids of today don't have the opportunities to have hands-on experience like they used to. We're now raising inside kids in an inside world. It's just not the problem I'm here to talk about, but it is a problem that we do see as we move through the years. So more on this rudimentary animation concept. These slides are actually done by Dr. Pashal. And so when we see PowerPoint animation, it's often not smooth. This is particularly smooth, but he's particularly skilled at it. We see animations after animation after animation to understand the concept. This is still a 2D flat representation of a problem that's trying to show you something that's moving, but we're not actually seeing motion. We see like a stop motion or a step motion. As the same with this path as well. It's still a stop motion or a step motion. We can't see the 3D vectors that are in production. So the historical approach to this problem, after reading lots and lots and lots of papers over what people have done to tackle this problem, we see hundreds and hundreds and hundreds of basic animations and flat 2D representations. Everywhere you go, you can find these representations. So the technology is out there. We just need to take steps to harness that technology for the exact uses of what we need, this college or whatever college. So there's also a lot of people taking this and skipping this 3D step or skipping this 2D step and going into a really expensive virtual reality phase of interacting with problems inside the classroom, inside of a virtual world. So this particular paper, development of interactive 3D tangible models as teaching aids. This paper right here, written by, I will not say their names because I don't want to butcher their names. You can read them here. They actually built a factory in virtual reality so that people could go in and interact with that factory safely. And so they had an amazing amount of success with what they call spatial awareness, which is that problem that we were talking about earlier on, how if we don't offer that knowledge, kids won't ever have that knowledge of being inside that program. So say what you want. I know this is a very, very hard thing for some teachers to take on, but the onset of COVID-19 has revolutionized education. Maybe not from the teacher standpoint, from the student standpoint. It has offered or has brought up a really, really aggressive need to have digital models and animations and being able to put the information out reliably and technically so that people can understand it. Because if we're not in a classroom, I can't have a chance to hold up a pen in 3D and show you how it moves. So we have to figure out a way to show them that digitally, which is what we kind of seek to fix here. And so our pedagogical needs, I love that word, pedagogical needs, is on a case-by-case basis. So what we need to do is we need to develop teaching aids that make sense for the engineering classroom. Our solution thus far, we have developed 3D interactive vector diagrams. We haven't put much work into, we'll go into the problems a little bit later, but we haven't put much work into developing other 3D models. We have put a lot of work into 2D animations, and those problems are specific to the problems in the textbook, so that we've had a lot of great success with that. GIF development or GIF development, I'll say it both ways so everybody's happy. We develop GIFs on these 2D animations. That way we have a repeatable motion that's over and over again. Integrating interactive websites in the slides. And that's kind of, so I don't know how many people that know about PFET or Colorado Institute of Technology's physics integration. They have a website that has these wonderful interactive physics solutions on their website. And so as we throw out these PowerPoints that say, here's your lesson for the week for your online education, or here's your lesson for the week for your education, you can go through your PowerPoint and be able to interact with that website and interact with things that move, where you move them, not somebody necessarily showing you how to move it. So these are vector diagrams. So the first picture you see here, this is the picture that's in the textbook. So this is what we call a vector diagram. And so when we look at this, what do you see? You see two lines or multiple lines on a flat surface. You really don't understand the depth of which way that arrow is. Matter of fact, if you squint your eyes a little bit, you can actually see the arrow moving into the paper, not out of the paper. How we rewrite that is, or how Dr. Pashal has rewritten this, and actually kind of messed up a little bit, but he has rewritten it for different views so you understand exactly what that vector is doing. But when we view this vector in 3D, we can actually see what that model is doing. We can actually see how that model projects. This is another model that we have built. And so this is one of the problems about how these programs don't conversate really well. But this is a 3D model that we can
That's not here.
hang on, guys. We'll
Get back.
we're gonna get back to this.
There.
All right. So this is one of our 3D models that we can interact with personally. And so we can click and drag this model. And so there's a rule when it comes to vectors of the colors. Each cardinal direction has its own color, and each relative or resulting vector has its own color. So there's representations of, if we look back at this one, we can see that Typically Y is green, Z is blue, and X is red, and resulting vectors are gold, yellow, orange, whatever makes sense. The resultant vector color doesn't really matter. Unfortunately, when we're in presentation mode, you can't interact with this model. Whatever it was last is what it'll continue to be. But the model's still there that you can exit presentation mode. It shouldn't be that big of an issue. The biggest problem with this is you can see that it's a gray model and not the colored model. So you don't really understand which one's X, Y, and Z. And that stems from some conversational issues between program to program and color to color.
You put loading labels.
I'm working on that as well. That is another interesting issue that we tried and things don't like to. We got a pretty good so I actually had a much better representation of tangential motion that didn't get saved. But here's a 2D representation of what we call tangential motion. So what we mean by tangential motion is that something is tangent to the curve. I don't know how many of you guys remember math class. There's some math majors or some engineering majors here and some of them are English majors. So in other words, when we see tangential motion or what it means something is spinning, and we should believe that it makes sense that that block would move as well if that block's not situated inside that curve. So when we see the 2D representation, we don't really understand what's happening. When we can see motion when we draw something like this is actually a very bad description, but we can see that something is turning. But when we actually show the video of the GIF, we understand that there is a particle inside of a tangential wheel that is moving. And then after it leaves, we can see the straight line motion that makes sense mathematically when it says when it leaves a curved path, it will travel on a straight line from that curved path. When we see another 2D representation of a ball dropping, this is supposed to be the difference in velocity in X and velocity in Y, or Z rather, Z being up and down and X being side to side. We see that these balls are supposed to be hitting the ground at the same time, but how does that make sense mathematically? We can prove it. When we show an animation, we can kind of see it. When we show this animation, we can actually see that. Let's pause it. And we can see that we actually have this program is called Algodo. And we can actually see that the vector diagrams are there and in existence. I know that one's not showing up really well, but it doesn't matter. This program will show you all of the relevant vectors that come off of that model. And vector just means relevant motion. If we go, let's go back into. This is the pulley systems. And so what we're supposed to see here, right here, is an interactive model of, or a web page that we can interact with. And it was the security system on one side of the campus is not the same as the security system on the other side of the campus. This particular web page is locked out. But if we were to see that, we would see something along the lines of these. And this particular website is pulleys in motion and how that motion interacts with. So when we do this, we can actually, we can interact with the hand and we can change it from 0, 1, 2, 3, and 4 pulleys. We can interact with any of these free source or maybe not free source websites if we want to pay for them for that access. We can interact with these websites, or students can interact with these websites at one access point. So the problem continues. We haven't found a full solution. Here's our list of problems. PowerPoint and Microsoft problems. We ran into some really interesting color issues. I actually delved deep into these 3D files and renamed the colors, the color code on the files just to try to get Microsoft to understand what I was trying to do. And it still continues to give it to me in black and white.
That's all you see.
Yeah. So that's the color issues that we're referring to here. The animation programs are not user friendly. And but what I mean by that is it's not the animation programs through PowerPoint. I'm talking about true animation programs. What I have specifically used to develop these 3D models are MATLAB, GeoGebra, Algodoo, and Autodesk Inventor, which is a 3D builder program. These are not animation programs. These are engineering softwares to do real problems in real life. I would draw something, I would make a schematic of it and have it built in real life. This is not an animation program. Real animation programs, people go to school for years to understand these programs. So often we have a communication issue between an artist and an engineer on what exactly do you need to animate and how is it supposed to work. So we don't have many engineers that are artists, and we don't have many artists that are engineers. So the ones that are usually putting this stuff online because they're bored. They're not doing it online to suit somebody's specific needs.
There's not a niche filled with an animation program that is user friendly to an engineer for the purpose of simulation.
Algodoo is the only one, and it's 2D.
Okay.
Algodoo is a wonderful program, suitable for a lot of problems, and that's where we found the most success is these 2D animations. And then we get into PowerPoint animation, which here's another lovely one that I built. And you can see we're trying to show a rolling block, and we're kind of showing a rolling block. So PowerPoint animation is extremely difficult to show relevant problems, and it does not take into account the real physics of anything. It's PowerPoint physics, which is wild beyond comparison. General program to program conversation. So what I mean by that is when we go into GeoGebra and we build a vector diagram, I have to take that vector diagram in a 3DS model and I have to throw it somewhere else to be colored. And when I pull it out of there, it's colored, I send it to PowerPoint and PowerPoint says, no, it's actually gray. So there's a lot of program to program conversation that's missing. And okay, let's go back or not. Where'd my last page go? My last page just disappeared. All right. Okay.
PowerPoint's for bed.
That's the.
I heard you talking about.
Yeah.
It.
Yeah, I'm glad we have Dr. Pashaw here, who is the PowerPoint king. All right, so our best successes so far. We'll end on a good note, not a bad note. So as discussed before, by far the most success is the basic animations with Algodoo, and that's the least labor intensive to create an animation and create a GIF. It still takes time. Everything takes a little bit of time. But these can be very, very, very directed to a very specific problem from our textbook, and then we can animate that image. The downfalls to that are that image can't be interacted with once we publish it. Another amazing program that I find is the best success is the integrated web page, which I allude to PFET here, or PHET or FET for Colorado Institute. And that's interacting with pulleys. We can actually build things in there, but it's still only 2-dimensional. We see here a wonderful 3-dimensional model that we can interact with and we can play with. And this is a stock photo. So whoever built this is quite knowledgeable in this art, but still didn't direct it towards the thought of teaching. It's the thought of representation, not the thought of teaching. So there's a lot of things that we can work on in the 3D world. I think the 2D knowledge is there and it's really easy to interact with. We just have to take the time to make it relevant to the text that we're working on. 3D animations is still out there. And the integrated web pages are amazing. I think that's one of the better successes. Might run into licensing issues there, but that's nothing that a college can't handle. All right. That is all I have. Is there any questions?
I'll say thank you for. Are there, I mean, I've got questions, but I would refer to my colleagues if they have any.
I want to ask, so when you type, so it sounded like a lot of what you're kind of looking for, something like a physics engine. And you can interact with it, right?
Right. Algodo is a physics engine. What I would love to see is a 3D physics engine. I don't know, I'm not a program writer, so I don't know exactly what that would entail, but that would be the quote unquote coup de grace of what we want.
I think, I mean, I'm not saying like, in particular, I guess something that you want to look into for 3D physics and it'll be something like, I've messed with that before.
Interesting.
Speed and drop it and follow it.
That's much like Algodo.
Right.
Yeah.
But
Yeah. Yeah. They're incredibly difficult to use.
yes.
Yeah, to try to program something new into them. Yeah. So is this really just a reflection of the fact that prior to solving?
I think we're seeing some of that, right? How many physics teachers do you see under the age of 40? And how many of them do you see that are willing to be that are willing to integrate new technology?
Yeah, I'm just thinking like if you have that. I suppose in the old days. My father-in-law, so was doing spinal over this project. Engine.
Right.
And he still have it. And it's on his front space of his living room. And you can, I mean, I guess you could take it apart and see how it worked and see how everything worked, and the physics would work upon it being it's within the real world. And you think to yourself, yeah, why that must be easily replicatable in digital space. I mean, I've seen Star Trek and how it works. And yet it doesn't, it's not. Yeah, it seems like it's so much harder than you would think. Like I would have just assumed that all of these existed for you all in digital space automatically.
Yeah, and that's what I think a lot of people believe that. And in some ways it is. It's just not in a teachable model.
Right. I mean, it's there for like, I guess, corporations or what.
Yeah, so you can, like one of my favorite programs that I used for a living when I was a machinist is Autodesk Inventor. It's a wonderful 3D program, draw anything you want, put it in motion. But when you put things in motion, it doesn't show you the relevant vectors or anything like that. It just says, this is what it's gonna do.
That's good.
Yeah.
That's interesting.
Yeah.
So it's almost, there's all these tools that exist that don't do what you need them and they don't talk to each other.
Yeah.
No one built them with the idea that they'd be integrated.
That's right. It is. Yeah. Well, I've spent hours and hours trying to get these things to talk to each other to no avail.
That's great. I mean, that's a problem to identify to try to solve. That's fabulous. Sorry, other comments or questions? I don't know if any of our Zoom folk have any as well. Welcome to chat or throw them in the chat if you want.
Just would like to appreciate his work and efforts he has put. As you might already have known that he has been to Pathway Symposium, and now he's working on a conference paper for listening upcoming conference and hopefully join
Yeah, no, we're happily leaning on Dustin to present it. Which is great, because it's good stuff, and I think it's very interesting too. Any last questions or comments before we descend upon the cookies and coffee?
A horde of us.
It's delightful. All right, well, in that case, I will come back to the front and say thank you all for joining us. Thank you, sir. It's great. And I will go ahead and get this posted on the website or on the YouTube for for all time. People can go and interact with it there. All right. Thank you very much.